Think of the solar system model you saw in a middle school textbook. The planets lined up, shoulder to shoulder, brightly colored orbs practically touching one another as they orbit the sun. Every aspect of this spatial representation is a fabrication, designed solely to fit the entire system onto a single printed page. To grasp the actual architecture of our cosmic neighborhood, we have to scale it down. If we shrink the entire system by a factor of 10 billion, the sun becomes roughly the size of a standard grapefruit. On this exact same scale, Earth is the size of a single candy sprinkle. And to place it accurately, you would have to walk 15 meters away from that grapefruit. Keep walking. Jupiter appears as a small glass marble, and the entire asteroid belt, every single piece of rock and ice combined, would amount to less than half a poppy seed, spread across miles of open air. This is the reality of our neighborhood. Vast, pitch-black distances between microscopic islands of matter. To understand how this empty space was organized, we have to rewind 4.6 billion years. Before the planets existed, there was a giant, chaotic molecular cloud of gas and dust collapsing inward under its own immense gravity. That collapse was likely triggered by the shockwave of a nearby supernova. The explosion seeded the cloud with heavy elements and triggered a compression that eventually ignited the sun at the center of a flattened disk. Notice the circular frost line dividing the early solar disk. Inside, intense heat allowed only scarce metals and silicates to condense, forming small, rocky bodies. Beyond it, freezing temperatures and abundant ice created massive solid cores that swept up surrounding gas, expanding into giant planets. Strict temperature gradients, operating over millions of years, dictated the architecture of the system. Heat and ice engineered two radically different classes of planets. Yet even with these two distinct zones, the early solar system was packed much more tightly together than the one we inhabit today. This chart models an early configuration. You can see Jupiter, Saturn, Uranus, and Neptune packed closely together, ringed by a dense, ancient disk of icy debris. Planetary scientists refer to this as the Nice model. About 4 billion years ago, Jupiter and Saturn drifted into a precise 2-to-1 orbital resonance. This rhythm amplified their gravitational pull, acting as a cosmic wrecking ball. The ensuing push shoved Neptune violently outward, plowing directly into the dense outer ring, scattering billions of bodies. Many of these shattered remnants were hurled inward, triggering an era of relentless, violent impacts across the rocky inner planets. Meanwhile, the debris scattered outward encountered Jupiter's immense gravity. The gas giant acted as a bouncer, ejecting billions of objects entirely into interstellar space. By pushing through the debris, planetary migration hollowed out the system, carving the immense, empty distances we navigate today. The predictable orbits we observe today are the quiet aftermath of that ancient migration. We live in a temporary window of calm, but this stability has a strict expiration date. It relies entirely on the finite supply of hydrogen fuel burning inside the core of the sun. In roughly 5 billion years, the sun will exhaust that fuel. When hydrogen fusion stops, the internal pressure will drop, allowing the star to cool and expand. This diagram illustrates the sun's final expansion. It will swell into a red giant, 256 times its current size. In our scale model, this grapefruit expands outward, swallowing those tiny candy sprinkles, representing Mercury, Venus, and Earth, incinerating them. After shedding its outer layers into deep space, all that will remain of our star is a white dwarf, an extraordinarily dense, cooling core, roughly the size of the Earth. Over quadrillions of years, with the sun's mass greatly reduced, the gravitational pull of passing stars will slowly detach the remaining giant planets, pulling them away into the interstellar void. We inhabit a transient cosmic event, born in a collapsing cloud, organized by gravity, and eventually reclaimed by the dark.